Hello, my dear students. Welcome to my channel Mathematics Made Easy. In today's session, we will be continuing our grade 11 advanced EOT revision for term 2 exam. So here I am back for you with learning objective number 4, where we find the values of sine and cosine by using half angle identities. So on the screen, I have put for you the formula sheet for the double angle identities. We are going to be using them for solving the questions. So let's see what questions we are solving under learning objective 4 in today's session. Okay, so in this kind of question, there are 4 things that are asked to you. I will mark them and I will give you the formula sheet that will help you for this value. So first you need to find sine 2 theta. So this is 2 sine theta multiplied with cos theta. Then you need to find cos 2 theta. Now for cos 2 theta, there are 3 double angle identities, anyone you can use. I'm going to use cos square theta minus sine square theta. Why? Because in the first step, when we do for sine 2 theta, we will be already getting the value of sine theta and cos theta. Also, we are given the quadrant, so this is 0 to 90, so it's first quadrant. All trigonometric ratio will be positive. Then we need sine theta by 2 half angle and cos theta by 2 half angle. So remember, the difference is very simple. The formula sheet for this will be square root denominator same, which is 2. The only difference is in the sign of the numerator. So for sine it is minus, for cos it is plus. Okay, so for each of these questions in the session today, we are going to be using the same formula sheets. Also, additionally, we will be using a little bit of Pythagorean identity. So I will write it here. So for example, in this first question, sine theta is given. So we need cos theta. So I will use the Pythagorean identity. Cos square theta is 1 minus sine square theta. Okay, this will give me the value of cos square theta. So let's do this as first step. So to get my cos square theta, I will write it as 1 minus sine square theta. Let's plug in the value 1 by 4. So 1 minus 1 by 4 whole square. Open the bracket, simplify. So this will come out to be 4 square minus 1 over 16. So this is 15 over 16. Now this is cos square, but what do we need? We need cos. So therefore cos theta is going to be plus minus square root 15 over 4. Now because it is first quadrant, I will only take the positive value and reject the negative value. So this is my value for cos. Now I have cos theta value, already sine theta value is given in question, so we can plug it in here, and then my final answer for sine 2 theta will be 2 multiplied with the value of cos theta multiplied the value of sine theta. Now you can cancel 2 with this. So it's going to be square root 15 over 4 multiplied with 2, 8. So your final answer for sine 2 theta. Now cos 2 theta is just the square. So I already got cos square theta as this value. I already have sine square. So just plug it in all the numbers. Take the subtraction. So 14 over 16. So this is going to be my value for cos 2 theta. Okay. So you can just a little bit simplify because both have common 2 as a factor. So I divide by 2. So 7 by 8. This is the final answer. Now let's do these two also. Remember, the only difference is in the sign of the numerator and the denominator. Cos theta was this value. So I'm just going to plug it in here. So let's calculate, just to simplify our answer, 1 minus cos theta and 1 plus cos theta, which is the numerators here. And then we'll plug it in here and get the final answer. 1 minus cos theta is going to be this value, and 1 plus cos theta is going to be this value. Now we don't like radicals in the denominator, so we are going to do the rationalization. For rationalization, I can write it as 1 over 2 and then put the value of 1 minus cos theta, which is this value, 1 minus square root 15 by 4. Similarly, 1 by 2 multiplied with 1 plus square root 15 by 4. Take the LCM, multiply 2 with 4. So the final answer, I will write it here since we have less space, for sine theta by 2 will come out to be, after rationalization, 8 minus 2 square root 15 over 4. Now don't forget the square root symbol. So in the numerator you have square root, and cos theta by 2 will be exactly same value. The only difference is in the sign. So 8 plus 2 square root 15 of, that's your final answer for question 1. Similarly, do question 2. I will show you the answer key for these questions in the next slide. Now let's solve question number 3. Here you are given the value of cos theta. Also, you are given the quadrant, so this is 90 to 180. That means we are on the second quadrant. So I hope you remember after school to college. So in the second quadrant, sine theta will be positive and its reciprocal will be positive. Everything else will be negative. So when I apply Pythagorean to get my value of sine theta, I will be sure that I have to take only the positive value. So let's plug in minus 5 by 13, do whole square, simplify, take LCM, and this will come out to be 1 minus 25 over 169, which is 144 over 169. So this is value of sine square theta. I need sine theta. So I'm going to take square root of this fraction. Both positive and negative will come, but we will definitely select positive, 12 over 13. So I've got my sine theta, I have my cos theta, so my sine 2 theta is going to be the product of all of this. So let's just plug in the values. I put sine theta, I put cos theta, multiply. So result here is going to be negative, and the numerator will simplify to 120, denominator 169. So that's your final answer for sine 2 theta. Now we have to go to cos 2 theta. Let me just write it here. Cos 2 theta, already I've given you the formula sheet in the previous slide. So difference of squares. So apply, put the value, minus 5 by 13 whole square, and this value is 12 over 13 whole square. Denominators are same. Denominator will simplify to be 169. Numerator is 25 minus 144, so this will come out to be negative value. Okay. So we've got our sine 2 theta, we've got our cos 2 theta. These are my two answers. I will go to the next slide for doing sine theta by 2, cos theta by 2 half angle identities. And remember, we'll be also using there the concept of rationalization along with the value of cos theta. From the last slide, we have got the value of cos theta in the question as minus 5 by 13. We need to find the remaining two half angle identities, which is sine theta by 2, cos theta by 2. You already know the formula sheet for these two, so I will quickly write it for you and then just plug in the values and do the rationalization. So remember the shortcut we are going to use. If cos theta is this value, then 1 minus cos theta and 1 plus cos theta you can calculate, because that is the only thing which is differing in these two half angle identities. So let's calculate separately. So minus minus will become positive. So be careful of the signs, please. Take LCM. So this is going to be 13 plus 5 and this is going to be 13 minus 5. So we can now write this value as 1 by 2 multiplied with 1 minus cos theta. So this is 18 over 13, and this one is 1 by 2 multiplied with the difference. So difference here is 8 over 13. So just multiply, see if anything is cancelling. Yes, this cancels with 9. This cancels with 4. So this is going to be square root 9 by 13 and this is going to be square root 4 by 13. Now I also need to rationalize. If I take the square root in numerator denominator separately, then this is 3 over square root 13 and this is 2 over square root 13. Now to remove the radical in the denominator, I will multiply up and down with the same radical. So do that. So this comes out to be 3 square root 13 over 13 as the final answer. And this comes out to be 2 square root 13 over 13 is the final answer. So with that, we have completed this question and got all the four values. A little bit different is tan, but again, just like in sine and cos, we use Pythagorean. We will use Pythagorean here also. So 1 plus tan square is secant square. From here, we get secant theta. Then we do reciprocal, get cos theta. Again, we go to Pythagorean, get sine theta, and proceed in the same manner. All the four things which are asked in the question are still same. So I will use double angle identity here and half angle identity here. So the formula sheet will remain the same. I will quickly write it here in the separate corner so that you know what we are looking at and what we want. We want these four things. 1, 2, 3, 4. So this is 2 sine theta cos theta. I hope you will learn this formula sheet so that you don't do any mistakes. And then the radicals, denominator same, numerator difference of sine. Perfect. So these are the four things we are going to find. Let's do this. So I put the value of tan minus 8 by 15, do the square and get my secant square. So just simplify, use calculator, take LCM, and this whole thing will turn out to be the value of secant square, which is 286 over 225. Just double check your calculations, and then because from here we are getting the value of secant, and what we need is cos, so we will also take the reciprocal. Okay, so one mistake here is 9. So now this is secant square. I need secant, that will be plus minus square root of 289 over 225. So do that, and 289 being a perfect square of 17, so this is plus minus 17 over 15. Now look at the quadrant. This is which quadrant? Second quadrant. So in second quadrant, your cos theta, which will be plus minus 15 over 17, will be negative. So I take the negative value, ignore the positive. Now I need to calculate my sine also. So sine square theta is 1 minus cos square theta. Plug in the values. Take square, simplify, LCM, and this will come out to be, on simplification, let's do this. When we subtract, it comes out 4 over 289, but this is the value of sine square. Which one do we want? We want sine theta, and in second quadrant sine theta positive, so plus 8 over 70. Wonderful. We got cos theta, we got sine theta. Now we can plug it in here, multiply. Be careful of the signs, don't do a sign mistake, and just use your calculator. Similarly, here also cos square would be 225 over 289 minus 64 over 289. So do the calculation, simplify, and this will come out to be, I'll write the final answer here, 161 over 289 for this question for cos to theta. Similarly, for sine to theta, when you do the product, do the cancellations. So the denominator is going to be 289 because 17 multiplied with 17, and in the numerator you have 15 multiplied with 2 multiplied with 8. Don't forget the negative sign, so this will come out to be minus 240 over 289. Sine theta by 2, cos theta by 2. Similarly, you can proceed as we did in the last slide. You already have the value of cos theta, which is minus 15 by 17. Plug it in here, simplify, and you will complete your answer in a similar manner. Let's do one more similar question. Now here sine theta is given. You need to get your cos theta. So you will take the Pythagorean. Now I will be going a little fast because we've done a lot of practice on this. So I will put the value, square, use calculator, simplify, and this will come out to be square root 5 over 9. So now cos theta both sign plus and minus, but quadrant is given to be second, so cos will be negative. So I just choose minus square root 5 over 3. So I got my cos theta, I have my sine theta, so I can find my sine 2 theta now, which is the product. Just plug in the values, multiply everything, and if you don't do any silly mistake, your final answer would be perfectly correct. So minus 4 square root 5 over 9. That's the answer for the first one, sine 2 theta. Let's do remaining. Cos 2 theta. So already I gave you the identity many times. I hope you all learn it. Difference of squares. So I put the value of cos, square it, put the value of sine, square it. So when you do that, one mistake, this value has to be sine, so we will just change it very quickly. So sine theta is 2 by 3. So now your denominator is same. You can take LCM, so it will be 5 minus 4 over 9 or 1 by 9. So that's your cos 2 theta. Perfect. So we are done with the first two. We're just left with half angle. Let's do them also. So sine theta by 2 I do here, cos theta by 2 I do here. So 1 minus cos theta by 2, 1 plus cos theta. So just simplify it a little bit more so that we can do correct value while we do the rationalization. So I will take this cos value and try to find, maybe let me just make some gap. So 1 minus cos theta separately and 1 plus cos theta separately. Let's do it. So 1 minus of minus, correct? And here 1 plus minus. Now I take LCM. So this is 3 plus square root 5, and this is 3 minus just the difference of a sign. Now I take these two values, 1 minus cos theta, 1 plus cos theta, and plug it in here, considering that this can be written as 1 by 2 multiplied with this. So this is 3 plus square root 5 by 3. Similarly, this is 1 by 2 times 3 minus square root 5 by 3. Now before we proceed, you will see that the denominator here is coming square root 6. Can you see that? And there is also a big square root outside, don't forget. So the big square root also has denominator square root 6. So square root 6, square root 6. We do this to rationalize. So when you do the final answer, it will come out to be for sine theta by 2 as 3 plus square root 5, and this whole thing is multiplied with square root 6. With square root 6 on the top. Denominator square root 6, square root 6. Khalas, the radical goes. So you will just have 6 here. Similarly, this one, cos theta by 2, will have the same answer. The difference is sine. So 3 minus square root 5 over 6 square root 6. So that is the complete solution for question 12. Similarly, do question 13. Now let's do question 14 and then you can try question 15 yourself. Here cos is given, so we have to find sine. So sine square theta is 1 minus cos square theta. We use Pythagorean. So 1 minus 3 by 5 whole square. Simplify. Take LCM. So this comes out to be 16 over 25. Now this is sine square. We need sine theta. So I will take the square root, and both plus and minus are there. But this is my third quadrant, so sine is going to be negative, so minus 4 over 5. This is my sine theta. So now I'm ready to get sine 2 theta. We can just plug it in the numbers and multiply. So sine theta minus 4 by 5, cos theta 3 by 5. Multiply numerator with numerator, denominator with denominator. You get a negative sign, and this is my answer. Let's move ahead and do cos 2 theta now. So same identity is going to help you. Cos square minus sine square. Put the values, 3 by 5 whole square minus 4 by 5 whole square. So this is 9 over 25 minus 16 over 25, definitely it will give you a negative value, so minus 7 by 25 is your answer for cos to theta. Sine to theta done, cos to theta done. We are left with half angle, so we will first calculate 1 plus cos theta and then 1 minus cos theta. Okay, cos is this, so 1 plus 3 by 5, 1 minus 3 by 5. Take LCM, so 5 plus 3, 8 by 5, and this one is minus 2 by 5. Let's put it in the formula. So your sine theta by 2 is square root 1 minus cos theta by 2, and your cos theta by 2 is 1 plus cos theta by 2. So let's plug it in. So in place of 1 minus cos theta, I'm going to put minus 2 by 5. There's already a half here, don't forget. And in place of 1 plus cos theta, I will put 8 by 5. So now you know we have some cancellation. 2 goes with 2. Here it is 4. The final sine theta by 2 value after simplifying, cancelling the term is, this is plus. So this is going to be square root 1 over 5. We do the rationalization to remove the radical. So in the denominator we have 5 and in the numerator we have square root 5. Now similarly for cos theta by 2, after rationalization you get square root 4 by 5, square root 4 by 5 by 5. So this is 2 square root 5 over 5. Final answer. So now we are finally on the last question of our learning objective 4. So here tan is given, so we'll find secant square. We'll use the Pythagorean identity, 1 plus tan square equal to secant square. Plug it in these values, take the square LCM and get your secant from here. So this is going to be 3 square plus 4 square over 3 square. So if you simplify, this is 9 plus 16, 25 over 9. Perfect. Now this is my secant square. What I need? Secant. So I'll take square root of 25 over 9. So this is 5 over 3 for me. Again, both signs plus and minus. Looking at the quadrant, we are going to divide. So this is my third quadrant after school to college. So we choose negative value. So how much is your cos theta? Minus 3 by 5. So from here we can get sine theta, square root 1 minus cos square. Plug in the values. So 1 minus 3 by 5 square. Simplify and your cos comes out to be, sorry, your sine theta comes out to be minus 4 by 5 because sine is negative in third quadrant. So now we have sine, we have cos, we can get sine 2 theta, plug in the values. Sine theta is minus 4 by 5, cos theta is minus 5 by 3, minus 3 by 5, let's remove this. So we replace with minus 3 by 5. Nothing cancels, minus minus becomes plus. So 24 over 25. That's the value of sine to theta. Similarly, do cos to theta and the remaining ones. Now, in a similar manner, we've done so many questions, so I would want you to finish this yourself. So cos square minus sine square, just plug it in the values. Minus 3 by 5 whole square minus 4 by 5 whole square. So this is 9 minus 16 over 25. So this will give you minus 6 by 25 as the cos to theta value. Proceed with half angle identities and complete your questions. Now I'll be providing you the answer key for all the questions we did today so that you can check your answers. Okay, so I'm doing just one more last question. This I found pretty important, so I'm doing separately for you. And if you see here, the quadrant is given to be second, so I know only sign will be positive, rest will be negative. So here I've also provided with you in pink color the answer key. So this is my value of sine theta by 2. This is my value of cos theta by 2. So I really wanted to show you the uh, steps required for rationalization so that you can reach to the correct answer. So let's do it. So tan is given, so we will use the Pythagorean identity for tan. Substitute the value minus 2 to get my secant square. Simplify, so 1 plus 4 is 5. So my secant square is 5. I need secant, so I will do the square root and get two values, plus and minus, definitely, because in second quadrant secant is negative. I will be choosing the negative value. So from secant I get my cos reciprocal. So cos is 1 over secant. So this will be 1 over minus square root 5. So I've got my cos, this value. Let's find sine. So sine theta is square root of 1 minus cos square. I plug it in the value. So 1 minus, remember this square will give you positive value. So 1 by 5. Subtract, take LCM. So this is square root 4 by 5, which is 2 over square root of 5. So I have the value of sine, I have the value of cos. Let's find sine to theta. So this is 2 sine theta cos theta. I put the value. Sine theta is 2 over square root 5. Cos theta is 1 over square root 5. Don't forget the negative sign. So in the denominator, radical goes 2 with 2 is 4. So minus 4 by 5. So that's correct. As you can see, minus 4 by 5 is the answer for sine to theta. So we are done. Let's go to cos to theta. So for this, we take the difference. So I will do uh, cos square theta minus sine square theta. Cos square means this square. So it will be 16 over 25. Sine square means this square. So it will be 4 over 5. Okay, so now I take LCM, try to simplify my things. Oh, one mistake we did, we put the wrong value here. So let's correct it. So cos square means the square of cos, and cos was this value. So square will be 1 by 5. Now we are fine. So now you just do the subtraction, take LCM, make common denominator. 1 minus 4 is minus 3. So have we got the correct answer? Let's check. Yes. So this is also done. So these two are easy. Now we proceed to the last two. So for that, I hope you know we need 1 plus cos theta, we need 1 minus cos theta, we need to do good amount of rationalization. So let's do it. So first I'm just plugging it the value of cos theta, which is negative. Look here, it's negative. So if at this step I want to just remove the radical, then what will I do? Up square root 5, down square root of 5. So I know this value is square root 5 over 5. Don't forget the negative sign. Similarly, this is square root 5 over 5. And here, because of the negative sign, you will see negative negative will become positive. So this one. Now I make denominator common. So 5 plus square root 5 over 5. This is the answer for this. And for this one, it is 1 minus, or I would just write the final thing now. Okay, better. So we have the value of 1 plus cos, 1 minus cos. Just plug it in the formula sheet. So sine theta by 2. 1 I will do, then similarly it is same. So 1 by 2 times this value. So this value is 5 plus square root 5 by 5. So just multiply, what do you get? Numerator is, let me just write it in a better way. So I can write for sine theta as 5 plus square root 5 over 10, and here there is a square root also, don't forget. So we can cancel 5 from up and down. So what is left finally? This value. So this is my sine theta by 2. Similarly for cos, the only difference will be sine. So if this is plus, this is minus. Fine. So that's how you finish your rationalization and complete this question. So here I've provided you the answer key for question 1, 2, 3 and 4 from learning objective 4. This is the answer key for question 5, 6, then 12 and 13. And lastly, this is the answer key for question 14, 15, 16, and 17. And that brings us to the end of learning objective number 4 for today's session. I hope you found the video useful. And if you did, don't forget to like, share, and subscribe to the channel. Coming up for you are more videos. Stay glued, and all the very best for your math exam. Bye-bye.